Hello there, TrekWorks with you again. Well, today I'm going to show you guys a little bit about some of the stuff that I use for doing the lighting and wiring on some of these model kits that I've been building, and just go over some of the basics about how to use wires, LEDs, resistors, things like that, and give you an idea of what it takes to light some of these things. Now, what I'm showing first here is a couple of different types of wire that are available, and one of the really good ones that I like to use is this wire here called magnet wire. It's approximately 30 gauge. It's got a plastic coating on there, and it's very, very thin and flexible, and it can fit into really tight spaces in some of those models. And I did a little review on it earlier and showed you some of the principles of it, but that's one of the type of the wires that's out there. When you go to do your soldering on this wire, there's no stripping required, because just the heat from the solder gun will melt down this covering that's on here, and it will give you the bare wire, and you can tin that and then solder it to your bulb or to your connection or whatever you're working with, and it makes a really good bond, and it's just really simple to work with. The other type of wire is your standard wire. This is about 20 gauge wire here. I use basically red and black for positive and negative throughout the model. And one of the things that I like to use is this handy dandy stripper right here. Now, there are different kinds of wire strippers that are available on the market. Your standard, squeeze and pull type. I really like this type because it actually automatically adapts to the size of the wire that you're stripping, and in just one quick motion like this, you have your wire stripped. It also has a cutter on the bottom side here on the edge, so if you're cutting wire, you're simple as that. Now I'm going to show you a little bit about preparing the wire. Let's just take a length of wire here and say we're going to use this on wire this into the model or make a connection with it. We'll strip both ends here, and then what we're going to do next is basically we're going to tin this wire with a little bit of solder. And if you don't have one of these here, get yourself a set of these. This is called a helping hand or extra pair of hands, made by X-Acto. This thing's fully adjustable with these little alligator clamps on here. You can use this from everything from doing this wiring that I'm going to show to holding parts for painting and all kinds of different things. So it's around $20 at a hobby store. It can be found elsewhere, but it's a really handy little tool. So I'm going to stick this wire in here like this, and my solder iron's already warmed up. I'll bring this solder iron into the picture for you here too. One of the things that I use for my solder iron is I keep a wet sponge, and in between each little job that I do or connection that I make, you just lightly wipe your tip on the sponge there, and if you can see in the video here, it's really clean and nice and shiny and bright. It gets rid of all the debris. Solder doesn't like any kind of debris or anything mixed in with it for a good connection. And the solder that I like to use for this basic wiring of this type is what's called 60-40 rosin core solder. That means it's 60% solder and 40% rosin. And what that does is the rosin promotes the bond to make the solder stick to the wire as it heats and bond to it properly. And so you can do it separately with just straight solder, and you can buy separate resin that you brush on or dip your wire in the resin, the rosin, and get that bond on there before you solder. But this is already built in, and it works really simple. You just basically heat your wire up here. I like to do it from the bottom side to make sure when my heat's built up enough so that the solder will penetrate all the way through. And you just barely put a little bit on there. Maybe move your solder iron back and forth a little bit, just to make sure that that wire is completely coated on the top and the bottom. And you can see we've got a nice tin, what we call a pre-connection there, a tin on the wire, so that the wire is prepped. When we solder additional solder onto this to our connection, it will make a bond instantly. And so that's what's called tinning wire. What I'm going to do now is I'm going to come back and I'm going to set up my breadboard here, and I'm going to set up my power supply and show you how we go about wiring some of these LEDs, and how to choose the proper resistor and some of the different circuits that are available for that. So we'll be right back in a second. Alright, we're back again to show you some basic components of LED lighting for model starships. And one of the things that I like to start off with, and I'll talk to you about, is the basic types of LEDs that are out there. We've got our standard LED, which a lot of you are familiar with. It's just a single bulb available in many different colors. This one happens to be green, and different sizes and shapes as well. You'll see some of these being round like this one. Some are square, some are rectangular, some are more button type. But the basic configuration of LEDs is the same except for the lens here. Now you can see that if you look up close at one of these, there's just kind of an inner little diode in there. It's a light emitting diode, and the rest of this whole area here is just kind of the casing that it's sitting in. So if you're doing some small work on some of these star chips, you can actually grind some of this down with a Dremel tool, or sand it down by hand, or file it down to make it smaller, as long as you don't actually get to the point where you grind down too far and touch that inner mechanism in there, that diode, and destroy that to where it won't light. But you can take these down a little bit, and these are available in different sizes. This one's a 5mm. There are some that are smaller, 3mm, 1mm, all the way up to 10mm, which are quite large, and in different intensities. And one of the important things to remember about an LED is that you cannot overvolt these. They require a minimum amount of voltage to light, which in most cases is 2.2 volts DC. By that I mean it requires a minimum of 2.5 volts to make this even light up. So it's not like a standard bulb when say your batteries are going dead in your flashlight. When it gets down to a certain point, that it will just get very, very dim, but you'll still see it. These will actually just cut completely off once the voltage is below 2.5 volts. And then there's also an amperage limit, and on most LEDs, there are variances on some of them, but most LEDs it's 20 milliamps. So you don't want to exceed 20 milliamps as far as the amperage that's going through this thing, or it will burn it out. Running these at too much voltage and too much amperage will definitely cook them, and you'll notice it when you hook it up. It'll be extremely bright, and it won't last but a matter of an hour or even less, and it'll be gone. So that's where this little guy right here comes in. This is a resistor. This limits the amount of voltage that can reach the bulb once it's hooked up to a circuit. Now, I just mentioned I'm using that little DC power supply, and for example, if I was running it at 9 volts and I wanted to find out what type of a resistor I need to connect to this light to make sure I don't burn it out, there's a little formula for that. So what you want to do is you want to start off with your battery voltage, which in this case will be 9 volts, and then we want to find out what our forwarding voltage is on our LED, which means that what I just mentioned, the minimum voltage it takes to light this up, which is 2.2 volts, okay, DC. So the formula for that is to take your battery voltage, which is 9 volts, and subtract the 2.2 volts, which leaves us with 6.8. All right, and then you want to take that 6.8 and divide that now by the amperage limit that these bulbs are rated at. In this case, it's 20 milliamps. So we want to take 6.8 and divide that by 0.02 on your calculator, and you'll come up with a number of 340. Now that will be your value of your resistor. Well, when you look at standard resistor values, you'll see that there is no 340. So in the case when you come up with a number that's not standard on a resistor chart, you want to always go up to the next closest one. So the next closest one available is a 390 ohm resistor. So that would be the correct resistor to use, running it at 9 volts DC to make this bulb right in its normal operating range. Now you can play with that up or down just slightly on your resistor to maybe get an effect of making the bulb just a slightly little bit brighter or a slightly little bit dimmer if you're doing some special lighting of some kind. But just to standardly light the bulb in its kind of medium to medium bright appearance, normal appearance, you want to go with the recommended resistor. Now, one of the things that I want to point out too is that the resistors are pretty much standard for, this is considered a low voltage system, so a 1/4 watt carbon type resistor is what you're going to want to start with. So if you walk into Radio Shack, you're going to say, yes, I need a 1/4 watt carbon resistor valued at whatever your formula has given you for the value of the resistance that you need against that LED. And I'm going to go into a little bit about completing a circuit here in a minute and tell you how to do multiple LEDs and resistors and things like that and how we figure that out. But here's another product that's out there, and this is called LED tape. Now the nice benefit to this is that you can see here we've got a single connection on the end of this, and this single connection will light this entire strip. Now you can get these in strips, I don't even know how long they go, but you can get them in quite long lengths, and these are divided into sections of 3, so there's 3 bulbs on each section, and you are able to cut this. So if you want to light a smaller area, you can cut this down and you can make just these individual lighted areas, or you can light an overall area such as the circumference of a saucer on a starship, the lower hull, inside the warp nacelles, whatever you choose to do. These are available in several different colors as well, and different brightnesses and different warmths as far as bright warm or cool warm, or however you want to call it. But one of the important things to mention about this is whenever you decide to cut this, you want to always make sure that you cut this right along where one of these connectors are. If you don't do that, if you happen to cut somewhere in the middle of that, you're going to cut off part of the circuit, and the resistor will no longer be able to control it, and you'll have a bulb there, or possibly a whole section that won't even light. So that's one of the things you want to be aware of. What I want to show you now is I'm going to go ahead and light this for you. I've got my power supply set up at 7.5 volts. The LED tape requires a little bit more voltage to run than your standard LED. You can run your standard LED all the way down to 3 volts, but these require a minimum of 7 before they'll even fire. That's due to the resistors that they have in there. And so I've got my power supply plugged in, and that's plugged into my little breadboard here. I get these breadboards at Radio Shack. This is just a little board here with multiple plug-ins designed to be able to plug chips or different types of wiring into this, so you can do testing on the circuit before you actually assemble the whole thing and solder it all. So it's a really handy tool to have. And what I'm going to do is I'm going to go ahead and I'm going to hook this up. I've got it plugged in and I'm running at 7.5 volts. And one of the other tools I use here is this digital voltmeter. I've got it set up right now to read at 20 volts DC, so anything under 20 volts it's going to pick it up. And I just always like to check my my polarity to make sure that I'm positive to positive and negative to negative on my entire circuits. And we can see here I'm lighting this up at 7.6 volts. And if I head it backwards like this, you'll see the little negative sign appear there in the window, which tells me I've got this backwards. As you progress when you're soldering your circuit together, you always want to periodically go in and test that to make sure that you have this right, so that you don't accidentally cross something and have half of the thing dead when you go to glue the whole model shut, or at the very end when you don't want to find out if you have a problem. So what I'm going to do here is I'm going to just basically plug this in, running at 7.5 volts, and in this case we don't need a resistor in between because we've got internal resistors built into this this LED tape already, and you can see it's really nice stuff. It has a nice even glow, it lights up nice and even, and it will light up a really nice wide area too. Again, you can get this in long strips, and with the tape on the back side you can mount it to things. Some of the models I've done have actually made little brackets and things to set this on. Say for example, if you wanted to do it in the middle of a fuselage or a lower hull of a starship, you could make yourself a little piece of using some sheet styrene, a little kind of tray that this sits in the bottom, and stick this to it, and it will light up kind of, or maybe one on each side of it, and it'll light up both sides of that, the window sections of your ship really nice and even. So it's a really handy kind of thing to have. And but again, it doesn't work in really small areas where you may want to apply something like a single LED, where you've just got a little flashing unit, or you've got one single area that's supposed to be lit. So they both have their uses. Now, getting back to this LED, there are different types of circuits that you can do with this, and the first one I want to talk about here is a what's called a series circuit. And the series circuit basically allows you to take, for example, and take these LEDs and wire them together in a group, and you start off basically bringing your positive side up to your LED with your resistor in between, and your value of the resistor. To get that formula, it's a little bit different. I'll talk about that in a second, but you're jumping from bringing it in on the plus side on the first one, and then you're coming with your current through the bulb and out on the negative side. The negative side then connects to the positive side of the next bulb. Power goes through that, out, back to the positive side of the next bulb, and then out the negative side, and then back around finally to your negative side of your battery or your power source, and you have a completed circuit. And in that particular setup, only one resistor is required, and there's a little bit different formula for that. So basically what you have to do is you have to figure out how many bulbs are being used in your circuit, and you multiply that number that we talked about a minute ago, which is the forwarding voltage of this bulb. In this case, normal forwarding voltage on most LEDs is 2.2 volts. So you want to make sure that you go and say we're going to use 3 LEDs, you want to go 2.2 times 3, which is 6.6, and then you'd subtract that from your 9 volts that we started off with, and that would give us 240. Okay, so then you'd round that up to your next highest resistor, and that would give you the proper resistor value for making these bulbs be supplied with the correct amount of current. So, and again, only one resistor is required for this type of a setup. The drawback to this type of a circuit, a series circuit like that, is that if you have one bulb failure in any part of that chain, the whole thing's not going to work. It basically breaks the circuit, and it also limits you as far as you cannot exceed, in that particular setup, you cannot exceed your input voltage. So we just came up with that number of 2.2 times 3, which was 6.6. We could probably get, with a 9-volt battery, we could probably get one more bulb in there, which would bring it up to, that would be 8.8. And then you could see that one more bulb beyond that, we'd be above the voltage that the power supply is giving us, so then we would not be able to light the bulbs. So with on a circuit like that, you're looking at four bulbs maximum of that, with that type of power coming in, and that's the limit for that. Now the second one I want to talk about is what's called a parallel circuit. The nice thing about the parallel circuit is that it allows you to run as many bulbs as you want, but you're going to use more resistors, since each bulb will be required to have a resistor on it in the circuit. And basically how that circuit works is you're coming up with power. Your plus side will go to a resistor, and then you'll connect that resistor directly to the plus of the LED, and then the negative will go back to your battery source or your power source, and each one of these connects individually to the you can bring a power wire up, and you can connect that to each one of these LED plus sides to that main power wire coming up, but you've got to make sure that you've got a resistor in between on each one. So each bulb will require a resistor, and that goes back to the formula we started off talking with, and that is that you figure out the resistor value for a single bulb, which we came up with before, which was 390 ohm. In this case, we're using 9 volts. So you're seeing that we're now, and in this particular case, we can connect as many LEDs as we want, basically until we would overconsume what the milliamp rating of that power supply is. But like I said, 1700 milliamps. We're drawing less than 20 milliamps on these bulbs, so you can think about how much, that's quite a few LEDs that you could hook up to a 1700 milliamp power supply. And the beauty to this also is that if any of these bulbs fail or something happens to your part of your circuit here, you've got power going to each one of these individually, and all the rest of the stuff is going to stay lit. If you're using this in a battery situation, it will light, but the battery will be consumed much faster because you're drawing just overall more current setting it up like this. Setting it up in series like I showed you allows your battery to last a little longer, but it limits you to how many LEDs you can have, because you cannot exceed with the number of LEDs in that series circuit, you can't exceed what the input voltage is, or you won't be able to light it. This is a switch. This is a basic switch that I use. You've seen it on some of my model kits that I've done where I mount them on my little stand, and I've been asked about how to wire these up. Some of you guys are beginners at wiring, and basically what you're looking at on this switch is that you're just interrupting either the plus or the minus power coming in. So you've got a plus and a minus. And so what you'd want to do is, for example, I've got my plus coming in for my power supply. I'd want to run one side of the plus to this pole, and the other side of another wire coming off this to my circuit, so that basically when I have this button shut like this, which means that this circuit is closed, that means current can flow through it, and it's just basically going straight through as if a whole complete wire was there. When I release this button and open the circuit, it cuts off this flow here, and so the lights go out. And you're basically just interrupting the current flow. And you can do that on either the plus or the minus side of the circuit. It doesn't matter which. It will just interrupt the power there, and it will either turn your lights on or shut them off. So it's very simple in wiring up a switch. Alright, so what I've done is I've set my power supply down to 4.5 volts now, and I'm going to set this little circuit up here for you. Again, talking about these LEDs, you've got your anode here at the top, which is your positive side, and your cathode, which is your negative. I'm going to go ahead and plug in the negative, which is the shorter of the two, on the negative side of this little strip here. And leaving the positive one up in the air like that, I'm going to go ahead and connect this resistor onto the positive side. And I'm just kind of twisting it on here, so it'll just hold for a second. And then I'm just going to stick this into the positive side. And presto, you can see we've got a lit LED working in the proper range. It's lighting just right. It's not too bright, it's not too dim. Set up with the proper resistor, the LED will last, I mean, a long, long time, thousands of hours. So it's just a really simple formula, but it puts you right in the ballpark of where you need to be on your LEDs. Having LEDs that are over too much current going to them, they'll look nice and bright, but as I said, you can get your entire model put together and then find out a couple days later that it's going to burn out on you. So just kind of stay within that limit. Just go to the next one up to be on the safe side. Like I said, if you come up with 340 and you notice that there's not a 340 ohm resistor, you go to the next available one on the upside, which in this case would be 390 on the 9-volt circuit that we talked about. So there you have it. That's basic LED 101. There are some other more advanced things out there for getting LEDs to blink and things like that. There are little timer chips available. If you search around YouTube a little bit, look up the 555 timer, and you'll see that there are little timers that you can set up on this with capacitors and resistors and things that'll give you the different effects that you want for, say, your flashing strobe lights, your blinking nav lights, how to dim some lighting. You can actually dim dimming an LED. The proper way to do that is not to reduce the voltage to it. The proper way to dim an LED is to basically flicker the current going to it at a kind of the higher you cycle it, the brighter it is. The lower you cycle it, the dimmer it will appear. So there are chips that are out there to actually cycle this bulb so fast the human eye can't detect it, but it makes the bulb appear dimmer. So there are different methods out there for doing that, but this is just the basics for lighting. Again, using that parallel method that I talked about, where you can connect multiple LEDs. You can basically put as many LEDs as you want inside your model, just making sure you got the proper resistor connected to each one, and you'll be able to do all the lighting you want, and it should work properly for you. And then connect your switch. You can do a lot of little fun things, like maybe connect your warp engines on one circuit, where you can individually switch those on and off. Do all your hall lighting on another circuit, put the switches in between. You can shut off the others, like I showed you kind of what I did on the Enterprise C. So there you have it, LED 101. Hope you enjoyed it. If you have any questions or anything, if I can answer them, go ahead and feel free to send me a message on the video board there, and appreciate all the followers, and hope this information helps you out there. So until we see you again, happy modeling.